In the previous lesson, we talked about law of sines, and in law of sines, what we did was we would take an angle and we would go across and find the opposite side. In these examples here, there's a variable missing, and that's okay, but we have to have, one of the key things I said in the other lesson was we have to have an angle in a side given, an opposite side given to use law of sines. And so if we look here, we don't have that happening in this example. All right, over here we have three sides, but all of the sides have missing angles. And so the criteria is we have to have a side and an angle that's opposite from each other, and we don't. So in these examples, we need something else, and there's going to be a law of cosines. Now, some of you are already thinking there's got to be a law of tangents. There's not. So it's just law of sines and law of cosines. All right, so here is what the law of cosines looks like, and it's very, very, very confusing, I would agree, especially the first time. So again, remember that the small letters represent the sides, the capital letter represents the angles. So what's really being shown here is that depending what side is missing, there's different formulas for it, but in general, the formula is the same. Okay, and the important thing to say is, what is the angle in the problem? Because whatever the angle is, this side that is opposite it is going to be like the single variable, or sometimes I'll call it like the lone ranger. So that's going to be by itself. So in this problem, we have this and that, and those are the two things that are opposite. The other two sides in this problem are going to be these two sides. And so if we look, we have a side angle side type problem where something will be given or missing, and then we have the side opposite that. So if you get this visual picture in your mind, I think it'll help, because eventually you're going to get a problem and it's just going to say solve, and you have to determine if it's law of sines or law of cosines. And so visually, I think you'll see that this kind of helps. It almost looks like a sun or an arrow being shot out or an angle bisector. Visually, I think you can put something to that picture. All right, so just to show you how this also works over here, if we had B, angle B, right, the two sides that go with angle B are C and A, and so then you see that picture as well, okay? And then the same thing would be for C. Okay. All right, so here's when we need it. If we have side angle side, that means we have two sides and an angle in between. We're going to try to find the side opposite that angle. That's one criteria for using law of sines. Cosines. The other criteria is if we have all three sides, we can find any of the angles listed using law of cosines. So here's a story problem that they start with, and so we draw a triangle here. We have the Earth and two stars, and the two stars are listed as 9.5 and 4.6 light years away from Earth. So the astronomer observes the stars. The angle between the stars is 43 degrees. So right now we notice that we have a side angle and a side, which is one of the criteria. So this is what we're trying to find, is the distance between the stars. So in the equation then, the side opposite the angle is going to be by itself, okay? And then we plug in the rest of the values. So the two sides are squared. These two can switch places as well. This -2 in the formula here is part of the formula. So it's a -2 times the two sides. So that's just part of the formula. Some people get confused where that comes from. So if you notice, these are the two sides in the side angle side, and then these are the same two sides here, and then we have the angles. So that would be our setup. Now, what's really cool about this is it looks confusing, but it's pretty easy to calculate, because we could do all this step by step if we wanted to, or what we can do in our calculator is hit the square root button and then type all of this under the square root and then hit enter, and we would end up with approximately 6.9 as our answer. Okay. So, and if you're not able to do this on the calculator, then we have to break it down step by step. So you would figure out that these two go here, this part would go here. Okay, so without that calculator that has the option to give you the big square root, you may run into some calculation struggles initially, but it can be done. Okay, it can be done. All right, let's try this one here. Now this one isn't really a story problem, it's just a setup. So one of the criteria again is we have side, angle, side. And so in this case, we're gonna find B. So in our formula, the side opposite the angle is gonna be by itself in the equation. The other two side lengths that are given go here. -2 times those two side lengths and then cosine of the angle. Right, so in the calculator, if you do that, that will take you right to the answer. If not, we can go through the steps here and you would end up getting 71.4 as your answer. So in this case, the equation will be given to you for this. You just have to know how to plug in the appropriate values and then use the calculator, okay? All right, so now finding angles. If we're trying to find an angle, we're gonna need that -1 button again. But in this time, it's gonna be cosine -1, cosine -1. So in this case, draw a triangle. If they don't give you the triangle, again, draw it, label it based on the problem, and it doesn't have to be to scale, okay? So now they want, this is where reading is gonna become important. Find the angle of the measure opposite the longest side. So what, in this example, the longest side is 14, and they want the angle opposite that, which is here, okay? So now when we set up our problem, this goes by itself in the equation. All right, now, there's a couple ways to do this. There is a shortcut to this, but for now we'll work a little bit of algebra and then the shortcut will be given to you guys. So we're gonna square everything and we're gonna multiply these three numbers. So when we square these three numbers and multiply that, this is what we get. Okay, now we're gonna add the two squares, which are these two, and then we'll subtract the squares, and then we're gonna divide by the coefficient of the cosine, in this case, which is that, and then do cosine -1, okay? And then we would end up with a value of 88.26, okay? So when we look at what happened here, the original value is here, and then we subtract off the other two sides. So the side opposite, okay, squared, then we subtract the other two sides, squared, correct? So we subtracted these two, and then we're gonna divide by this -2AB, and the AB is really just -2 times the sides. And then we will take the cosine -1 of that, okay? So that becomes the shortcut, and we'll talk about that in class. So if you hit cosine -1, parentheses, use the ND button, type all this in, you should get 88.26 as your answer. Okay, so make sure you write that down and work through the examples that we have here, okay? So again, here would be the shortcut equation. Would be such, okay? All right, so here we go. So 9, 11, 14, find the angle of the shortest side. So the shortest side is here. Here becomes our angle. So we set up our problem, we square and subtract and then divide, and then take the cosine -1, and we would get an answer of approximately 40 for that, okay? All right, so in this case here, in example 5, this is the last example on the notes, you may need to actually do both. You need to maybe find the law of cosines first, and then do the law of sines to find the missing values. So in this case, again, plug in the values. So the angle 126 is here, side S is over here, and side T is over here. And you notice we have side angle side being given. So we can find this side first. Using law of cosines, we can find this. If we did law of sines, we can't, because we have a missing side here and we have two missing angles. So we don't have a given side for law of sines. So if we find this, then we can find the other angles using law of sines, okay? So here, because we're trying to find a side length, we can plug all of this in the calculator, and when you square root it, you should get about 83.9 or 84. Now we can use this pair to find the angles listed. So in this case, I'm gonna find T, angle T here. So sine of T divided by 53 in that. So go back to the law of sines. Where's the variable at? It's on top. So we're gonna start opposite, cross multiply, and then divide. And because we're trying to find the angle, we're gonna use -1 as our button. And you should get approximately 30.7 And then to find angle S in this case, we would add up the two angles and then subtract them from 180. So I know this is pretty confusing. We do spend a lot of time on it. And I do encourage you to come back and review the steps of these particular problems. It's really about following the steps of each of the problems over and over again and being aware of what you're doing.